Organic. In an organic reaction, carbon is the star of the show.
Yes.
Okay? If they ask you what you need to be organic, the answer is carbon. There will also be hydrogens, oxygens, nitrogens, and other things involved in organic chemistry, but the star of the show is carbon. Carbon can make 4 identical covalent bonds. That's what it says right here.
Good afternoon. Happy last day, everyone.
Carbon can make 4 bonds. Here they are. Long chains, networks, and also add the word ring here. All right, rings. Hydrogen can make 1 bond, oxygen can make 2, nitrogen can make 3, HONC, 1, 2, 3, 4, if you want to remember it that way. I don't know why you would do that. Molecular formulas show the exact number of atoms. Structural formulas show what the structure looks like. Condensed structural formula just shows the structural formula squashed down so it's on one line. Let's show an example of that. Let's do C5H12. Okay, that's a molecular formula. So we know that it has 5 carbons and 12 hydrogens, but we have no idea what it looks like. Okay, if I draw the structural formula and I draw all 5 of my carbons in a line, make sure you put all of your hydrogens around the carbons. I'm not drawing every H out there. That is a structural formula. And finally, if I do a condensed structural formula, it would look like this. CH3, I've got a carbon with 3 H's. CH2, I've got a carbon with 2 H's. Then I got another CH2. Then I've got another CH2. And then finally, I have a CH3 at the end. Okay? That is a condensed structural formula. It's just the structural formula squashed down so it's on one line. I can also draw an isomer of this C5H12 that would look like this. 1, 2, 3, 4. Take 1 carbon off of the end, stick it on a middle carbon, not on an end carbon, must be on a middle carbon, and then go back and make sure all of your carbons have 4 lines around them.
Wait, why can't
Because if it's on the end, it's just bending the chain. It's still a long continuous chain. It's still 5 in a row. If I put it up here, I can still take my pen and trace it to 5. Here, I either go here or I go here. Longest I can get here is 4. Okay? These are isomers of each other. They still have the same molecular formula, C5H12, but they have different structural formulas. This is the structural formula. Now let's write the condensed structural formula. CH3, CH, CH3, that's a little methyl group hanging off of that carbon. CH2, CH3. That is a condensed structural formula for this guy. Now, let's name them. What's the name of this?
It's 5.
Has 5, so it's a prefix.
Pent.
Tent. Okay? All single bonds, so it's ane. Pentane. This guy down here, the longest continuous carbon chain is 4, so it's bute. All single bonds, so ane. But it's got a baby hanging off of carbon number 2. So it's 2-methyl butane.
How do we know if it's like methyl?
Methyl has 1 carbon, ethyl will have 2 carbons, propyl will have 3 carbons. Okay? I'm sure that's down here somewhere.
Can we do one by ourselves and see if we can get the name?
You want to get the name of it?
Yeah, that's fine. I need a fan text, one of your reference tables.
Let me put all the H's on there. All right, let's try that. What do you need?
Reference.
Yeah. Find the parent chain.
X. Wait, so there's 2 and 4, so what would you do with that?
Find the parent chain first.
1, 2, 3, 4, 6. 6 is hexane.
Hexane. Here's a baby, here's a baby.
2.
2 and 4. How many methyls?
2.
2. Dimethyl hexane. 2 methyl groups, and they are on carbon 2 and carbon 4. Okay, what about this one?
Phylloxes.
I know. Well, I have to make it big because otherwise. Hold on a second. I'm not done. Let's do that.
So there's 9. 3, 4, there's 8.
There's 8. 8.
Octane.
Octane. Here's the
It's not
baby.
methyl anymore. There's 2, right?
No, it'd be
What's that baby's name?
ethyl.
Ethyl.
2 ethyl.
There's another ethyl up there.
3, 4 diethyl.
3, 4 diethyl. Good. 3, 4
Oh, this is easy.
diethyl.
Why'd you look at me like
Easy.
that?
It's easy when you know what you're doing.
Yeah.
Okay? I could have easily put an ethyl group here and a methyl group here. Then it would have been 3 ethyl, 4 methyl. But you see you get the picture.
Do a really
Okay?
big one.
No. All right. Alkanes, alkenes, and alkynes are called homologous series. The alkanes are saturated. Alkenes and alkynes are unsaturated. They have a double or a triple bond. Sometimes they say, in terms of bonds, why is this an unsaturated hydrocarbon? It is an unsaturated hydrocarbon if it has a double or a triple bond. If it's all single bonds, it's saturated. Isomers I just went over. Naming these suckers, longest continuous carbon chain. If there's a double or triple bond, that has to be where it is in the parent, and that has to be at the lowest possible number. Look for branches and name them, either methyl, ethyl, propyl, whatever, and how many of each branch, di, tri, tetra, so on and so forth. That's what we were just doing here.
Right.
Okay? All right. Alcohols, aldehydes, acids, esters, ketones, ethers. I can't read that. Amines, and halogens. Halocarbons. Halocarbons are the easiest one because they're named just like this, except for now the baby is either a bromo, a chloro, a fluoro, or an iodo. You're going to put that on there just like this. Let's put a fluorine there. These all have hydrogens on them. Now I've got ethane, and fluorine is on carbon number 1. So it's 1-fluoroethane. What about this one?
It would be.
This one right here. Name your parent first.
3, 4.
Butane.
Butene. Where is that double bond?
On the first 2 carbons.
1 butene, right? Between carbon 1 and 2. Use the lower number. Okay. Where are these bromines?
3.
Carbon number 3. 3,3-dibromo-butene. Di means there's 2 bromines. The numbers tell you where they are. Go ahead, Jack.
You have to do 3 because a double bond, like, as to start the double bond. Whatever it is.
When we name the parent, the double bond has to be at the lowest possible position. So the double bond is between carbon 1 and 2.
Yeah,
Once I knew that was 1 and this was 2, then this has to be carbon 3.
Yeah, that's fine.
All right. All of these guys, alcohols, aldehydes, acids, they're all on your reference tables. Table R. Look, here it is. Table R. Here's your halide. Use the example that they give you in order to name your compound. What do you name?
I'll give you a pass.
No, I don't. Oh, okay. Okay. Alcohols have the functional group OH. Okay? If you see an OH and it's on a carbon chain, you are dealing with an alcohol. No matter where it is on that carbon chain. Like this.
Someone text me.
Okay? This is an alcohol. Happens to be a secondary alcohol. You don't need to worry about that, but it is an alcohol. How many carbons?
6.
6. Hex. How do we end an alcohol's name?
Propanol.
Anol. Where is that OH group? Carbon number 2. Stop talking. 2-hexanol. Okay, that's alcohols. Ethers, the oxygen is in line with the carbon, and the way the ether is named is that you name either side of the ether. Methyl on one side, ethyl on the other. Methyl, ethyl, ether. If you have something that looks like this, what's the name of that guy?
Ooh, I don't know. What's the 4 carbons? So
No, not 4 carbons. You got 3 carbons here, and you got 1 carbon there. What is it called when you have 3 carbons?
Prop.
Prop. Look at how they named theirs. They said methyl. I'm going to say propyl. And then this side has 1 carbon, so that's going to be methyl, and you're going to write ether after it. Methyl propyl ether, or propyl methyl ether. Either way, they should go in alphabetical order, but I don't care.
Wow.
Just get them down on a piece of paper. One side is propyl, one side is methyl. Okay? Look at your answers key here. It will tell you. Just change the prefixes. The next one is an aldehyde. An aldehyde has an O, double bonded O and an H at the very last carbon. 1, 2, 3. I think that's the example they gave you. Let's make it bigger. Okay? That's an aldehyde. How many carbons do they have in theirs? 3. They had propanol. How many carbons do I have in mine? 6. So it's hexanol. All I did was change the prefix. Determine how many carbons you have. Can I draw a isomer of hexanol?
Yes.
How can I do that?
You can do.
Say it again.
My reference table is right below it size.
Okay, so the aldehyde and the ketone are isomers. I can draw a ketone that has 6 carbons, and I'm going to get an isomer of it. Or I can take this double bonded O, which is on the last carbon, and move it to the center. Okay, so I can take this. I have 6 carbons. I can put it on not the end carbon like it was. So don't move it over here. It's still an end carbon. Move it to a middle carbon. Once I move it, I can go back and I can make sure every carbon has 4 lines around it. That is now no longer an aldehyde. It is a ketone, but it is an isomer of that aldehyde. I would strongly suggest you guys pay attention. Okay, so what's the name of this ketone? Okay, how did they name their ketone? They have 2-pentanone. The 2 tells you where the double bonded O is, and pent tells you there's 5 carbons. Well, I've got 6 carbons, so it's not pentanone anymore, it's hexanone. And where is my double bonded O? Be careful. What number? 3. 3-hexanone. Not 4, 3. Because counting this way is 4, counting this way is 3. You always want your functional group to be at the lowest possible position. All right, so aldehydes and acids and ethers are isomers. Aldehydes and ketones are isomers. Acids and esters are isomers. Okay? If it's an acid, your functional group is at the very end. If it's an ester, your functional group is going to be in the middle of the carbon chain. That's why there's 2 blank spots here, R and R. The carbons can go off on either side. All right, look at these two. This one is an alcohol. This one is an ether. When you have an ether, you're going to know it's an ether because to the left of the oxygen, there's going to be hydrogens. I know I've said that before. Okay, so this is an alcohol. This is an ether. All right, let's do an aldehyde and a ketone. An aldehyde is going to look like this, where the double bonded O is at the end of the carbon chain. I did ethanol, so I will now do ketone. Oh, I can't do, hold on a second, I can't do that ketone because there's no middle carbon here. So let's make this a little bit bigger. CH2, CHO. All right, now let's get rid of that. You see how that's still on the end? I couldn't make a ketone with the double bonded O on the end when there's only 2 carbons. There's no end. There's no middle. Okay, so I had to make it 3. So CH3, CO, CH3. That's going to be your ketone. This is going to be your aldehyde. And then finally you have your organic acid and your ester. Okay, your organic acid is going to look like this, COOH. And your ester is going to look like, I did it again, I should make them bigger. CH3, CH2, COOH. So CH3, COOCH3. Okay, this is an ester. This is an acid, organic acid. When you have COOH at the end, you have an acid. When you have the COO in the middle, you have an ester. When you have CHO at the end, you have an aldehyde. When you have a CO in the middle, you have a ketone. When you have an OH at the end, you have an alcohol. When you have an O in the middle, you see the difference between these guys? Okay? Ether, just the O. Ketone, CO. Ester, COO. When you were looking at a condensed structural formula, that's what you're looking at. Kind of. All right. They're right here.
Yeah.
The amine and the amide are very easy to recognize. The amine has a nitrogen but no oxygen, and the amide has a nitrogen, but right next to it, you're going to have a double bonded oxygen. That's all of this section right here. All given to you on your reference table. All right, then we had the types of organic reactions. Do I have space on here to write? Combustion reactions are always some sort of organic compound, CH4, plus oxygen yields carbon dioxide and water. This part never changes. Okay, for a combustion reaction. If you look at table O, it could be wrong with that letter. Is it O? I lied. It's I. Okay? The first 6 on here are your combustion reactions. Notice that they are exothermic. They give off enormous amounts of heat. Not as much as a nuclear reaction, but for a reaction, they give off heat. Combustion just means to burn. Think of burning a log. If you're burning a log, you put your hand up to it. The log is giving off heat. The log's reaction is exothermic. Your hand is endothermic. It is taking heat in. Heat goes from where it is hot to where it is not. All right. Addition and substitution reactions. I'm going to start with the substitution reaction. A substitution reaction happens between an alkane and let's just make it bromine for now as a halogen. So let's say I have ethane. There's no room to put these bromines on there. So what I have to do is I have to take the hydrogens off. So it looks like this, C, E, C. Here's hydrogens. I'm going to take hydrogens off here. I'm going to take these two hydrogens off. Now that bromine is going to go there. Okay, one bromine goes there, one hydrogen comes off, and I end up with HBr. This hydrogen came off. One of these bromines went in. Substituted. That happens when you have a saturated hydrocarbon. You can't make any more spots because it's saturated. There's no more room at the end. So the bromine has to kick somebody out. That's why you end up with two products. An addition reaction is a little bit different in that you are going to start with an unsaturated. Who's out?
Jack and James.
What period is this?
But
Today is 13th.
Yeah.
All right. In an addition reaction, it is an unsaturated hydrocarbon. That means you must have a double or a triple bond somewhere, which when I add the bromine to it, that double bond can break. When it breaks, now have an extra bond spot. I'm just writing them in green so you can see them. Those two open up. Now the bromine has some place to go. Whereas here, it didn't have any place to go. You couldn't make more bonds. Okay? An addition reaction must be an alkene or an alkyne. All right. That takes care of this one and this one. See where it says add to a double or a triple bond, unsaturated only? That means there's going to be an alkene or an alkyne. Substitution has to be an alkane. All right. Esterification, another biggie. If you have esterification, you are making an ester. An acid plus an alcohol make an ester. Acid, let's take C double bonded O, OH. Let's take ethanoic acid. I don't know what this little thing is here. Ethanoic acid. And let's take propanol. I'm going to put the OH over here just because it's easier for me to show you what's happening. Take that water out. This oxygen is left. And it joins together and you make C double bonded O. See the double bonded O? O, C, C, C. I'm squeezing it on here. Okay? That is an that's an ester right there.
yes.
Because you've got this functional group. And there's your functional group. What's the name of that? You're going to name the alcohol first. Just like they do on the reference table. Right here. What's table R? There it is. Okay. Methyl, the right side is your alcohol. The right side is your alcohol. Methyl, and then prop for the left side, propanoate. Methyl propanoate. This side is going to be propyl, and then I got 2 here, ethanoate. Propyl came from the alcohol, eth came from the acid. The right side of your ester is your alcohol side. The left side is your acid side. Can you not do that and break my chair? Thanks. All right. So you need to know esterification. An acid and an alcohol gives you an ester. Esters smell good, like fruits or like peppermint, maybe. Spearmint, peppermint, wintergreen, that's all esters.
Is that what I smell when I like smell those magic?
Yes, that's exactly. The Mr. Sketch markers are all esters. Saponification is making a soap. James, I am at my last nerve. Saponification is a fat plus a strong base. You can't see it, but it says NaOH there. You're going to make soap and a glycerol. Glycerol is a trihydroxy alcohol. It is like a lubricant. Okay? Saponification, the first 4 letters spell soap. If you can't remember the word esterification or saponification, do making a soap, making an ester. Okay? If you can't remember esterification or saponification, write down making a soap, making an ester, making a polymer for polymerization. Okay? You will still get it right. And then finally, you have polymerization, which means you're taking a repeating unit, whatever that happens to be. In this case, I'm making it an alkene. Okay? And you're going to see an N in front of it. It's on tape. Watch it. N, and you've got an alkene. When you make the polymer, actually, yeah, like that. There's going to be an N down there. If they take water out, it is condensation polymerization. You're removing water. If they don't, then it's just addition polymerization. They don't get crazy about that. Don't worry about memorizing condensation. Just know it's polymerization. If you see these ends, this means there's multiple of this unit. This means there's lots of those units strung together. And they have like a little thing coming out of the parentheses to show that's where they're hooking up to the next guy. Okay, that's why I drew that little line out the side there. So these are all of our organic reactions. Any questions on organic?